Loading this one up at the shop in Texas, heading up to Adam in South Boston, Virginia. You can see the 53-foot flatbed all loaded up there and ready to head out. And then fast forwarding a few days later, they took delivery and it sat for 2-3 days until Chris and I could fly up there. And we helped him get it all into its final location. We got there on a Sunday afternoon and went ahead and went in as soon as we landed, and then made the 1.5 hour drive from the Raleigh airport to go ahead and do a little bit of work Sunday evening so we could hit the ground Monday morning with real activity. But you see here, we're just getting everything moved into place using a pallet jack forklift. These laser machines weigh about 5,500 pounds, so they're not terribly difficult to move around. You go down. Yeah, let's get it closer to the ground. That's good. And here you see Adam was putting together the monitor stand. And you see his overhead crane there. We'll show you more about that and show it in action here in a little while. Very nice crane setup he had there. And then here's Chris getting everything prepped to get the laser head mounted. Fiber cable ran from the source up to the head, and then the head mounted.
Trying to start off with this at start?
Yes, sir. Oh, you guys have seen me show the fly cutting feature many, many times on these machines, mostly just showing off how cool it is and for fun. But this is actually a real world application here of a part that Adam makes on a regular basis. He's been making them for a while. He's involved in the round track racing scene. I can't remember if it's dirt track or asphalt, but he is involved in some software related to that field. And then he also makes quite a few different kinds of parts for those cars, in addition to tons of other stuff that you'll see in the video. But this one particular part has a lot of holes in it. It's thin aluminum. I think it's 060, like 16 gauge aluminum, somewhere in that range. I don't remember exactly what it was, but you can see the fly cut move here, how the head never lifts, the gas delay is turned off, and it does nothing but move in a straight line and cut the circles out that are in that straight line. And really slick, really fast, fun to watch. And it is a big boost to productivity when you have to cut a lot of squares or holes or features that are in a straight, sort of a grid pattern. What you need to put your rivet holes in there?
They do it.
They do
It's
it.
different.
Oh, it's different for each application. The back of it. Pretty nice. I mean, like, there's nothing on the back of those holes. Just dirt from this sheet, but
Yeah,
the
dirty
actual
ass sheet. That's about it.
gravity. All right, go ahead. All right, don't take it out. Okay. Let's just say, for example, man, I'm sorry about that. I meant to have a big 1.5 inch circle in the middle of this.
Okay.
I know you've already cut it, but I still want a circle in there.
How do we do that?
Well, let's draw a circle. Yep, anywhere, that's fine. And then make it 1.5 inches. Man, your eyeball was really close on that. 1.48. All right, then highlight everything but the circle. Or actually, just select the circle in the outside. Leave the others alone. Select the circle in the outside. The outside is always the outside shape. Yeah, there you go, yeah. Now center it. All right, and now select everything but the circle. Yep. And then disable it by clicking the red X right there.
This one?
Nope, at the top. Top right. There you go, right there. Yep. Now it's disabled everything except for that, but it's kept your position as the start point down here so it knows where it is. So now if you hit start, it'll go cut the circle. Now we're talking. Now that was funny right there. I was trying to give him a lesson, and I was just kind of filming it to show this one capability. If a hole doesn't cut or you need to add something you forgot, how you can easily go back and add that. But you got to make sure the part's secured in its position, because it was micro jointed in there on the opposite corners, and that high pressure 290 psi of air blew it up, and then it tried to, well, you saw what happened there. And with a laser, stuff happens super quick. So, but anyway, I thought I'd leave that in there. I was trying to capture a little bit of a lesson, and this is what the installs are about. 3-4 days of showing you how to do all the different things and what can happen. And that's what we do. So here's a look at Adam using his vacuum lifter. Super nice rig he's got here. The overhead crane is rated for 1 ton, and the vacuum lifter was rated for 1.5 tons. So most any kind of plates that this machine will cut, which is rated. This is a 3,000 watt machine, by the way. It'll cut 3/4 inch max. So I think even a 3/4 inch 5x10 sheet is going to be under the 1 ton. So he can pretty much do anything he wants with it. I think this is either 1/4 inch or 3/16 cut with oxygen here. And if you don't know, on a fiber laser, when you cut with oxygen, it's interesting. It leaves these little it's not really a burr and it's not really on there. It sort of just sticks to it. It's the, you know, it's the evacuated displaced material, and it sort of magnetizes itself and sort of wants to kind of stick back, but it just flakes right off. If you even, you know, drop it or touch it or anything, it comes right off of there. But you'll see this part and how good we got the fit up there for this aluminum machine piece going into a laser cut hole. And I think we were cutting another one here, and we used the kerf compensation tool in the laser console to tighten up the tolerance on that even a little bit more, even though it was already a really good fit. I think it's just on a slat, but yeah, check it. It's got a micro joint on it, doesn't it?
Yeah, I think so.
Pause it again after this is hooked out. There it goes. I really don't know what it is, but every laser has at least one material that will absolutely give you fits trying to get it to cut right and dial in. And it'll be just a random, you know, like the material above it and below it will cut just fine, but one material, and maybe it's just the drop that you're using, you know, I don't really know what it is, but this was it for us on this one. I can't remember, you know, the details. We did eventually get it and got it cutting pretty nice. And you'll see the drops, and you'll see the comparison here too of you know, the work we were doing. And here's just some random shots from around Adam's shop with some of the other stuff he does. You see the big powder coating setup he's got in the back, a big blast area, and then the actual oven. So he's well set up there with coating. And then there you see his crane and laser under that. He had a plasma table. It's actually still in there, but we moved it out and put the laser in its place. See the pre-pierce? When you start to get into thicker carbon steel with oxygen threading on a laser, heat becomes an issue, and you have to start to try to do a few things to help with the heat, you know, to preserve a good cut quality. And here just demonstrating, I think this was 1/2 inch, and you'll see the two parts here, both are the same part, one with about a 100 thousandths radius on the corner, and the other one trying to do a square corner. And you'll be able to see the one with the square corner has got a defect in the corner, and the one with the radius has got a nice smooth cut all the way around. So if your part can withstand the radius, that's an easy way to solve it. If it can't, there's other methods. You know, we didn't show them in this video, but I've shown them many times. Cooling point, ring cut, you know, a few other things that you can do. So this is 1/2 inch plate right here, and demonstrating a couple things. One is pre-pierce, and the other is some a little bit better techniques on piercing to get through faster. You can see the 1/2 inch edge there. Very nice for 3 kilowatt, hot rolled steel. Once you get above, say 3/8 range, the higher grades of steel, better, higher quality than A36 start to make a pretty noticeable difference in the kind of quality you get. But here's pre-pierce. 3/4 inch steel on 3 kilowatt laser is the max, and you can see we were getting through there very easily, and the pre-pierce just buys you a little extra cooling to help, your edge. Rough in places, doesn't it? It's not horrible, but not great either.
Better than the last one.
Yep. Go. So I covered quite a bit of stuff on a new install, not just, get the machine running and then run out the door. Like I mentioned earlier, it's a few days of training, and I spend a good bit of time training on troubleshooting the random error messages and things that can come up. When you're not looking, I'm going to put an error alarm in the machine, so when you come back to it, it's going to have an alarm. And what I'm really looking for is, will you panic? Will you be like, where's Gary? You know, let me hurry up and ask. Or will you like read the message and try to, you know, see what it is and take a little bit of time and figure out the problem? Because running a laser is not, you know, always easy. There are little quirks and things about it that you have to learn. The same as learning how to import a drawing, learning how to nest. It's the same part of the skill set of being a laser operator, of troubleshooting basic alarms that come up. Another thing that I show, not just how can we cut some parts, but what's the best way? You know, what's the best way to handle the parts and to make it easier? Like this is an example right here of, you know, micro joint placement, and then also, you know, nesting subgroups of parts together where you can pull the whole sheet out. Because Adam wanted to be able to cut these, and you can see he's kind of struggling with it, and we needed to tweak where we have the micro joints a little bit. But we want to be able to pull this out in a full sheet, run it through the belt sander, and then break things apart, instead of handling individual parts and running individual parts through there. So I was just showing him that, and we needed a little more refinement, but this was, you know, one step in that direction.
That'll be a better way for me to do this.
So if you wanted to, you could run that whole sheet through the belt sander in one bigger piece instead of dealing with all the individuals.
Yep.
Plus, it would come out of there easier because you have a little bit, you know, our little air cut burr that we've got on the back. You know, you'd have that gone. So that would make it easier. Yeah, so we're gonna wrap up this video here showing you a delivery from Alro, ALRO. Certain parts of the country have Alro steel distribution, and you can pretty much get anything you want delivered from them. And other parts of the country don't have access to that. And these guys also, you know, have their own lasers and stuff. So, but anyway, I thought it'd be pretty cool to capture. You know, the way Adam gets his steel delivery here, back in the whole trailer. Inside, you know, it was pretty cold and rainy when I was there in Virginia. But this is the method that he uses because, you know, right outside there is a little bit of a slope and not too easy to get access. So this worked out well. But